For solving linear inequalities symbolically, we can follow a very similar process to how we would solve linear equations symbolically. There's just two cases where we need to remember to flip that inequality symbol. One of those is if I'm dividing or multiplying both sides by a negative number. For example, in this inequality, I would get x alone by dividing both sides by -5. Well, if I divide both sides by -5, I have to flip this inequality symbol to make it a greater than instead of a less than. So that becomes x is greater than -4. To see why this is true, think about what happens if we start with just two numbers. Here's 0. Let's take two numbers like 2 and 5 on the number line. Certainly we agree with the statement 2 is less than 5. Well, if I come along and multiply both sides of this inequality by -1, then I end up with the statement -2 on the left and -5 on the right. And if I want it to be true, I can see that now, in fact, -2 is greater than -5. So that what happened when I multiplied by -1 is that everything got reflected about 0. These two numbers got pushed over to the other side of the number line so that we now have a -2 and a -5. And we can see that now that they're negative, the one that is further from 0 is the lesser number, not the greater number. We could extend this to handle the case where one was negative and one was positive, or where both were negative initially just by drawing separate number lines for each of those cases, but seeing it once is probably enough to just establish the idea behind it. Anytime I multiply or divide both sides by a negative number, it's like a combination of multiplying by -1 and scaling by whatever that value is. So we have to flip the inequality symbol to reflect that change of position that happens with that. The second case is a little bit more obvious if we're switching sides. Like, for example, here I have the statement 3.2 is less than or equal to x. If I would like that to read with x first, I might flip the whole thing around. That way I can read it more clearly. To do that, I can see that the inequality opens toward the x initially. I need to make sure that the inequality still opens toward the x. And the way I do that is I think about flipping the whole expression around, including the inequality symbol, rather than just switching sides, which is something we might think about if it's an equation. So if I'm doing either one of those two things, I have to remember to flip my inequality symbol. If I'm not doing one of those two things, I probably just keep going and leave the inequality symbol alone. So if we take this first example here, we're asked to solve and graph. We do have a fraction in this, so I can start by clearing fractions just like I would do if it were an equation. I don't have to, there are other ways to do this, but let's go ahead and multiply both sides of this by 2 in order to clear the fraction. This is like 2 over 1, so this 2 and this 2 just drop out, leaving me with just a -1 multiplied by z minus 1 on this side. And on the right-hand side, I have -4z. Because I multiplied both sides by a positive number, I do not flip the inequality symbol in this step. I can distribute that -1 in to get minus z plus 1 is less than -4z. Now I want to get all the z variable terms on one side and the numbers on the other side, so I can go either direction. I'm going to choose to move the 4z over to the left by adding it, and to subtract the 1 over to the right so that this term is gone also. I now have 3z on the left, a less than symbol, and a -1. In my very last step, I'm going to divide both sides by positive 3. Because I'm dividing by a positive 3, I do not flip the inequality symbol. And I end up with z is less than negative 1/3. If I were to solve this in a slightly different way, I might have had to flip the inequality symbol once or twice along the way, but I should still end up with the same answer no matter what decisions I made. For the graph, I'm just going to go for a concept graph here. I don't need to mark a scale. We really just want to see where the endpoints are and what direction the graph is going. Since less than would go to the left, and this is a strict inequality, I will use this type of bracket, open bracket, and draw a line going to the left from there. We can now read our interval notation directly from the graph. This left arrow implies that that graph goes to negative infinity, and therefore my interval would start at negative infinity and continue up to negative 1/3. I'm going to use open brackets for both of these, an open bracket at negative 1/3 because of the strict inequality, and open bracket at negative infinity because recall that we always use open brackets at positive and negative infinity. When solving a compound inequality, remember this is a compound inequality because it has 2 inequality symbols in it and therefore 3 places. We can solve it all as one unit with the goal being, if x is in the middle here, the goal being to get x alone. We can solve this all as one unit as long as we follow the rule that each operation, instead of doing to both sides like we would do in an equation or a standard inequality, we're going to do each operation to all 3 places at once. So focus on where x is when deciding what your operation is going to be, and then make sure you do it in all 3 places to make sure you're doing a legal operation. So focusing first on the middle expression, 5 minus x over 3, I can see that division by 3 is what I want to take care of first, and I would get that away from x by multiplying by 3. So I am going to multiply by 3 in all 3 places. Now I ask myself, okay, is this the kind of operation for which I have to flip the inequality symbols? Multiplication by positive 3 is not, so I will go ahead and keep these the same. So in the middle, multiplication by 3 undoes division by 3. Those are gone. On the left, I have negative 6. In the middle, all I have remaining is 5 minus x. And on the right, I have 18. Again, focusing on x each time. Each time, come back to where x is and think about moving terms or moving multiplied factors away from x. I have to move this 5 before I can handle the minus sign, because generally we do added terms before we do multiplication and division, and I'm going to move that 5 by subtracting it. So I need to subtract 5 from all 3 places again. So negative 6 minus 5 gets me negative 11. 5 minus 5, those add to 0. This is still a minus x in the middle. I haven't done anything that would get rid of that minus sign. And 18 minus 5 is 13. I, again, don't flip these inequality symbols because adding and subtracting a number is not one of those 2 types of operations. Now for my very last step, I need to, again focusing on x, I need to get that minus sign out of there, so I am going to divide by negative 1. I could think of it as multiplying by -1, but sometimes division is easier to fit into the step. So I am multiplying or dividing by -1. This becomes a positive 11. In the middle, this becomes x. And over here on the right, this becomes -13. And I see that I need to, for this operation, flip both inequalities. You can flip them in place. You don't need to swap them. This one becomes a greater than or equal to. So that my expression now reads from greatest to least. I can flip the whole thing around now if I like to read things in increasing order. -13 is less than x, which is less than or equal to 11. Note that I do flip the whole expression around and both inequality symbols turn around, but I do keep the inclusive inequality with the 11, and I keep the strict inequality with the -13. So for my graph, I'll start at -13. I will go up to +11. I have a open bracket here at -13. I have a closed bracket at +11. And in between, I have a line. So this is everything in between. And my interval notation simply copies what I have on my graph. So the reason for flipping this around is that in this form, maybe it's a little bit harder to get to the correct interval notation. So we want to be cautious about this. If you don't flip the statement around, you can still get a correct answer, but that correct answer does not look like this. 11 to -13, right? We never write our interval notation in that order. It has to always be in increasing order. So somehow, by the time we get to our interval notation, we have to have it going from the lesser number to the greater number.